Now let's look at a class of problem called integer program. In particular, we're going to look at binary decisions, i.e. those go or no-go type of decisions. Here's the problem. A consulting company has 10 potential projects to take on, each with its hours listed here. It has 2 teams to take on those projects. However, no project can be shared by the 2 teams. Each team has at most 100,000 hours available. Now, since the hours are already budgeted, the firm would like to take as many projects as possible. The hours needed for each of the objects is here. Now, how many projects can be taken at most by the 2 teams? So now just looking at this inputs, it's very hard to tell how jointly the 2 teams how many projects can take on. So we're going to let Excel solve for us. So we're going to have 20 binary decision variables, the 10 for each team. And in each of the decisions, you can only take on 0 or 1. 0 means this project is not taken by this team. So a 1 would means that a certain project is taken by the team. So the advantage of formulating this way is that if we sum up in the rows, we get whether this project is taken at all by a team. If it is 0, then none of the team take this project. But if it's a 1, that means that some team is taking it. Also notice we can control that it will be less than 2, meaning that no project can be taken on by both teams. And in terms of calculating the budgeted hours, it's very simple. We just use a sum product so that we could immediately get the total hours for any given allocation. So again, this is the advantage of using binary variable. It only adds up those projects hours that are being taken. So we basically say here it less than 100 and 100. Everything is in units of 1,000, and that's why it is 100 instead of 100,000. And what's our goal? Well, our goal is really just summing up all the binary variables, right? If we want them to be as many ones as possible, so we're going to maximize that binary variable. So here's the solver part. Let's explain a little bit in detail. We want to maximize the total projects taken, maximize by changing the 20 variables, but they are not any variable. In fact, they are what we call binary. So the way you enter that is to say, select all of them and just choose here, bin, meaning binary. Okay, and there's also a budget constraint. So our constraint B30 to C30 is less than 100. So that's the constraint. And we also say our B18 to D27, D18 to D27 here is less than or equal to 1, meaning that no project can be taken by 2 teams, so that this indicator variable will be 2, so that's not allowed. It is a positive, everything is positive, and we're going to use simplex linear programming to solve it. Let's do it. So it is setting up, and you will see that it will give some kind of iterations, and this just shows that integer programming is actually a little bit more time consuming to solve, so we need to be a little bit more patient. Okay, now we found a solution.